Hello everybody, this is Nino, and in this video I'm going to show you my theory on reasoning with patterns. It is a continuation of logical triangulation, and here the focus will be on how an artificially intelligent agent can interact with the world and learn from the world. All this based on patterns, and how can we accelerate the reasoning rather than using logical triangles. Logical triangulation can indeed express any pattern by means of biatomar hierarchies. That is very precise, but any change in a lower relation will procreate and cause changes in the higher hierarchy levels as well. So you will be dealing with a lot of different patterns, although they might all just relate to a basic substrate of A, B, C, D. Now, that would work, but it would be slow. And I'm going to show you here an approach of accelerating things a little bit by losing a bit precision, and how such patterns can be used for learning and interaction of an artificial intelligence. The basic idea is all the system sees is sensory information, and these are the patterns. So how can we use these to teach an artificial intelligence to interact with us? My proposal is very simple: replace the structural precision with a more diffuse sense of connection. Like you say these three atoms belong together, but you don't say exactly how. And thereby you can reduce a lot of the hierarchy structures which come out when you are doing logical triangulation into a flat pattern. Now obviously you lose here some information. What you will gain is speed. In my experience and in my experiments, that usually suffices for quite impressive results, and I will show you later on some experiments. Still, some ideas can be preserved. For instance, patterns can still express more abstract and more concrete concepts. In particular, you can say that a large pattern can express an abstract concept. For instance, sunshine in the summer, a walk with ice cream in the park, listening to singing birds. You might call that a pattern expressing a wonderful day. Or if you look at more narrow patterns, you can look at more concrete, like more specific topics. For instance, three atoms might be the chocolate chips in Stracciatella ice cream. Something along these lines. But anyway, some reasoning possibility is preserved by reasoning just based on flat patterns. Now bear in mind, when reasoning with patterns, the only information available to an artificially intelligent system, and in fact also to any human, is sensory information. You never see the world. You're operating on patterns of input and output, but you only see what your sensors are showing you. And what sort of information that is a design choice. It is including time and space. You decide whether your system shall reason on time or reason on space. There is no a priori physical representation of the world to the system. That's really important to realize, as all the reasoning which I'm going to present you is based on patterns, not on some mysterious other influences. Now, what is reasoning with patterns in general then like? What can we say is a potential reasoning mechanism if it is all based just on sensory information? Well, I am saying you're having two fundamental components: finding the similarity between patterns and continuing patterns. For instance, let us say you meet a bear. So you're perceiving a challenge from the outer world. Then you recognize the similarity of the bear to the wolf, and you already know that from a wolf the best thing to do is to run away. Therefore you conclude from judging the similarity and finding out the continuation that you shall run away from the bear. So you are continuing the pattern based on your experience. And what is the correct evaluation of the pattern depends on how large patterns the system is really looking at, because that, as mentioned previously, will determine the level of abstraction possible for your system. A system which looks at larger patterns will turn out to be more intelligent than one which can handle only small patterns. For instance, running away in this case might not be the correct reaction if the bear is just your sweetheart dressed up in a bear costume. Then the bigger pattern shows you a more abstract level of reasoning, like we are having some little joke, a party or whatever, and it might be much more proper to hug the bear in this case. So a more intelligent system really is going to evaluate for its response larger patterns. Now, how can patterns be actually used in general to interact with the world and to learn from the world? I'm saying this can all be reduced to a very simple process, which I'm calling challenge-response learning. The idea is this. The system, some artificially or naturally intelligent agent, is challenged by something from the outer world. It tries to compare it to known things and gives a reply. For instance, this red thing is answered with this green thing. Like, the bear is answered by running away from experience. Now this is just a guess. You have to say that the challenge is similar to what you know. The next step is the learning step. You see, the outer world, which is determining the behavior of things and entities, is now itself being challenged by this green thing. It answers then with the red thing. And that is something which can be learned. That is, for all practical purposes of the system, an objective truth. It perceives that this pattern is answered by that pattern, by the outer world. So that is something which can be learned. Once again, the system is now in a position to guess its next reply as the outer world delivers this response, like this mountain-like structure. Then the system again has to assimilate it to its present knowledge and find the continuation and give you, for instance, this piece of clover or whatever it is. So you can say that the challenge from the world is guessed and receives a reply. And again, the outer world replies to that challenge from the system with a turned around triangle. Let's say it that way. Then again, the system can learn this. It can learn that clover is answered by triangle. So you're having here a potential exchange of guess, learn, guess, learn. By this, the system is actually enriched with knowledge during interaction. It is some sort of imitation which can be, so to say, imbued into the system without further effort. It just naturally follows from interaction with the outer world. I have actually used this even in an experiment with an Arduino. Even this not very powerful platform is able to make good use of challenge-response learning, and you might wish to check out my video regarding that. I'm also saying that this mechanism of guess, learn, and so on is sufficient for general intelligence. It may be a shallow intelligence, it may be rather stupid, not make much, not make a deep pattern analysis, but that's really still everything which is needed. You need to answer to challenges with responses. It would be better if your responses are good, but if your responses are possible, that's all that is needed. Now, how big is the challenging pattern? Like, how large is the thing with which the system is being challenged? How large is that what the system needs to reply to? I'm saying the smallest challenge presented to the system, the absolute minimum, is the absolute most recent piece of information received by the sensors, like the last thing perceived. That is your most recent token of information, and it is very limited. A more intelligent system is going to be able to reason on context, on bigger patterns. And an easy way of serving such bigger patterns for learning by the system is reaching further back into the past. That will generally give the system a bigger pattern to answer, like the last few interactions might constitute the challenging pattern. So you might really look at the pattern history when you are looking for handling challenge-response pairs. Not just what the system saw last, but what's the general situation in which the system is. That's very abstract. Let's give you a concrete example. You may say that if somebody says hello, you're going to say hello to you too. But if you look at the context, it might be that the pattern asks for a very different response than just hello to you too. For instance, if it is an axe-wielding madman, you might wish not to simply say hello to you too, but to run away screaming. Or it might be your sweetheart with a cake. Then, again, hello to you too might not be the most appropriate response, and you might wish to show a little bit more affection. These are different situations. And the context, so to say, the larger pattern, the more abstract pattern, is showing you in what way. In other words, to let the system operate on such larger patterns, you may use a sort of sliding window of history. The last number of interactions is going to each time be the challenge to which the system will need to reply. And obviously, the challenges will be partly overlapping. Some new sensory input will come and extend the history a little. Some older elements are no longer going to be regarded, and that altogether will determine the new pattern which you need to reply to. So, more context is going to make the system smarter. There is also one further mechanism which is going to have an effect on the system's interaction if it is handling input and output by means of challenge-reply pairs. I'm saying that newly learned patterns, newly learned challenge-reply pairs, are going on the top of its knowledge base. Things which have been learned a while ago are thereby coming more and more to the bottom as new things are accumulated and learned. And if you have just a finite knowledge space, some patterns, some challenge-reply pairs might be actually even forgotten. Now, when you have learned something recently and put it on the top of your knowledge base, then the pattern reuse will become also more likely. For instance, if you're having a pear and an apple and an orange, then if the orange is the present challenge, you have recently learned about the apple and some long time ago about the pear, then maybe if the apple and the pear are equally similar to the orange, you may say, I'm going to go for the newer match, as it is more in the current area of reasoning, and thereby I trust it more. So, more recently learned patterns in general, at least in my experiments, also exhibit more influence on the system's behavior. So far I have told you how you can use patterns, flat patterns, for challenge-response learning, and how you can match then challenges with responses. What some of you might then rightfully ask is, but isn't deeper reasoning possible? What happens with us humans? We are having some sort of inner world, aren't we? Wouldn't it be possible to implement that in an artificial intelligence too? I'm telling you, it is possible. By what I call here, I'm calling it resliding. You're resliding the challenge. Deeper reasoning can be implemented by challenge reply pairs in this way. You give a challenge, you find a response, and as shown before, the response finding process might generate further knowledge, which then may change the knowledge base. But you discard the response. You just keep the mutated knowledge base and again supply the challenge to the system. And then again you evaluate it. And so after several reconsideration cycles, the system might finally output a response. But this repeating of the challenge and searching for the response, and maybe in the meantime doing some further evaluations, can be counted as deeper reasoning, if you will. So challenge response pairs, while I use them usually just flat out by finding a challenge to something similar in the knowledge and outputting a reply, can be used for deeper reasoning if you really want to. So, what are the types and units of input and output? So far I have been talking about patterns answering other patterns. But I'm telling you, this is a design choice. Both the type of sensors and the granularity level of the sensors are axioms of the system. They are the elementary atoms which enter the thought space. There's nothing lower than them that your system could reason with. That is very important to keep in mind, as it determines the entire further conduct of your system. Nothing from other sensors or below the granularity level can be reasoned with. For instance, let's look at a chatbot, which for me is the fruit fly of artificial intelligence. Somebody had said that it's actually games, but I believe chatbots are really much better. I'm saying, let's say a chatbot is operating on whole sentences. Then this chatbot cannot adjust individual words within a sentence. Then individual words are beneath its granularity level. It is not dumber for that, but it can't reason with so fine information. Moreover, such a chatbot cannot see shapes of words either. If you had made it see the pixels, that would be a different story, but if you say whole sentences, then that's what you'll have to live with. Why am I saying that? Well, some people are judging the intelligence of artificially intelligent systems based on the sensors which these systems have. That's obviously nonsense. Like I have shown in a previous video, if you see a flower which looks white to you as a human, it might actually have a very interesting pattern in some other optical spectrum, which insects might see, but you will not. That does not make you dumb. It may only make you a bit blind to some of the beauties of nature. And the same is with an artificially intelligent agent. You judge the intelligence based on its ability to handle the patterns which it perceives, but you do not judge it based on the perception itself. Now, this is pretty complete so far, and I have shown you how to interact with the system, but two questions are now remaining. First, what does it mean to recognize similarity between patterns? And secondly, how does this system act at all? Now, I'm saying recognizing similarity is a design choice. It means concluding that two patterns are alike, but you are free to use any method you wish. And avoid fetishism towards some certain method. I have experienced many times in the past that people tend to be most impressed by that method which they least understand. They are totally into neural networks because it sounds so great, you know, like something neural, as if it has something to do with life or the brain or whatever. or Bayesian networks or whatever. I'm saying no, that's a design choice. You're free to take anything you wish as long as you can recognize the similarity between patterns and establish it. That's really whatever you want. I don't believe that there is the one method. Of course I have my preferences, but it's not an absolute thing, it's a design choice. It's an axiom of your system. And I am going to introduce to you also my favorite method, which is fragmentation sets, but that will be in the next video. So the point is, you must establish the similarity between the challenge and your knowledge in any way you like. Now, judging similarity is in fact already a sort of analogy reasoning. And I believe that this is also all that is necessary for reasoning by analogy, which is important as I regard analogy to be one of the two fundamental mechanisms of reasoning. I told you, you try to recognize something and you try to continue it. Recognizing, that's the analogy part. And I'm illustrating to you here how reasoning by analogy is already contained in the recognition phase. For instance, if your challenge is a bear, then you may say you find more similarity to a wolf. Then that is going to have a direct effect on your reaction as you are going to run away. Or the challenge might be like a sweetheart in a costume, and then you might wish to hug it, but you better be pretty sure of that, because hugging a bear might end up not so nice. So, the recognition of a pattern already determines the reaction of the system further on. So it is quite important that this is done correctly. And depending on how you do it, your system might react in unexpected ways, which are however correct for its design, though unexpected for you as a human. Let's say you tell your machine, "The lost state of human being breaks my heart." It is entirely possible that it replies, "Hearts are not solid matter and cannot break." These are design choices. You have designed it in a way to recognize patterns in some certain manner. And they have a direct effect on the kind of intelligence it possesses. It might still be intelligent, but it might highly displease you, which is not a valid matter for determining its intelligence. You must respect that an entity might be working and that your emotional dislike of it is not in any way a valid challenge to the concept of its intelligence in and of itself. This is simply how well can it interact with patterns presented to it. But if it can do it, it might do it in a different way than you do it. And think of it. Your specific reactions will be usually very different than the reactions of other people. It's not fair to measure the intelligence of an entity according to your emotional stance towards it. Now, what is the action? What can the system do? Again, I'm saying that is a design choice. I'm saying the elementary actions will have a direct influence on the behavior. Like a chatbot, it cannot walk anywhere. It can only output text. You can say in a chatbot it would be easy. You can say it will be words. Moreover, you can devise some reflexes, how thoughts turn into actions. I have already spoken about that in my previous videos, that you need such reflexes. That will again depend on what actions do you choose shall it have. The general idea is that some thought upon consideration will trigger actions of the system, and that these actions can be extended by further reasoning. They can be extended by means of analogies and can lead even to the discovery of new actions or combinations of actions. Think of the idea that a baby initially cannot write, but at some point the kid learns how to do it. But all in all, this is a design choice, and you shall be aware of what possibility of action you choose when you are devising such a system. Action, in this regard, is very similar to perception, because the sensors are also a design choice. So that's actually everything about it. I'm saying you just simply learn by exchanging patterns with the outer world, and even if you don't do logical triangulation, still the recognition of similarity between patterns will be quite sufficient to have intelligent interactions. In my next video, I am going to show you what I call fragmentation sets. It is a way which I have devised in order to determine the similarity of two patterns in an abstract way. My other favorite method are sliding vectors, where you're having a vector of past experiences which leads immediately to the next action. Regarding that, I'm going to show you a robot built on the basis of Arduino. So stay tuned, and thank you very much for watching. Goodbye.